So here we go. Last should be a good section before we do. I need a new page. Here goes, add a blank page. Go. Limits. So what we did is I want you to draw this picture. Your notes are going to leap a little bit on you. I want you to write this down for me. The limit as h approaches 0. Go to a clean place, maybe a notebook with lots of space. You need this. I'm going to write this expression here and tell you that this is the slope of a secant line, believe it or not, that we just did for, remember our average rate of change, me traveling from Minneapolis to Des Moines. This is actually calculating the average rate of change in a funny way. I will show you a picture that helps you understand that. You need to be able to recognize this image. So draw carefully and do draw. This is where you need the information. This is not memorizable. It takes a picture and it takes you engaging in writing. Okay? F of x. There's my f of x. This little expression that I'm writing right here, it's kind of fun. If I put my first, I'm going to call this x over here. And if I put x into my function, right here, just like that, I get the height would be f of x right there. Okay with that? That's it. That's called function notation. If I put x into the function, this would be the output I'd get, f of x. What I'm going to do is go over here and I'm going to do a point x plus h. Kind of weird. Right there. And the resulting output is going to be f of x plus h. Right, because that's a different height. Now if you get a sense of what I just wrote in there, x, and this being x plus h, that means the distance between these guys is h. I just went from a point x, whatever it is, I went over h spaces. What I'm going to do is I'm going to calculate the average rate of change between those 2 points. Okay? I want to know the slope of this secant line right there. Here it goes. We know how to do this. I'm even going to label this old school like so that you guys can see this in a different light. Let's say I call this old-fashioned thing y. You remember y2? Just do that. Remember this would be y1. Do you remember that? You'd call this x2. You'd call this x1. That's like a little aside, by the way. I'm just trying to give you a sense of. We would do, remember slope would be y2 minus y1 over x2 minus x1. That's how we did slope of secant line. Look over here, same stuff. I've got y2 is just that f of x plus h here, minus y1, just f of x, over x2, x plus h, minus y, x1. Now, what I don't have written in here is probably the full formula of this. I want you to see what it would be if I wrote it all out. This is just so you can see if I put in y2 is f of x plus h, minus y1 is f of x. I'm just rewriting it again. I'm going to actually write everything out so you can see it real pretty-like. x2 is this x plus h number, minus x1, which is just x. See what happens with x minus x? They go away. So x minus x cancels, and you get this lovely formula. Now, the limit as h goes to 0. You might be wondering, why do we put that out there? And what is the meaning of this? What would that do for us? Well, think of if I shrunk h a little bit, made it this much over. Okay, so I did h as a little bit smaller. And I did the calculation. What if I chose my plus h to be smaller? Look at my secant line. It's different. So I keep shrinking it. You got to watch this. Put your phone away. Shrinking that h. Shrinking that h. Shrinking that h. Holy moly. Look at those shrinking. As h shrinks, what do you guys notice happens to that secant line slope? Yeah, it's kind of decreasing, going down. Curvature of the graph, as I pull it closer, it kind of goes down like this. Does it, I mean, how far does it go? What's the limit? Like, where is the secant line going to go if I just keep getting closer and closer? By the way, a limit says h is never 0. It gets close, infinitely close to 0, but not 0. Think about what the slope of the secant line is going to look like as you get closer and closer and closer. Now I'm going to put a little, look at this mini one right here. Look how tiny that one is. Isn't that cool? Does anyone have a sense of what you get? Like what kind of, maybe think of what we've been talking about in the last couple of minutes. Is there anything that it's kind of headed toward? It's okay if you don't see it, but somebody might come up with it. I'm kind of excited. The slope at x. Bryce, you just nailed it. Nailed it. That tangent line slope, my odometer reading at that moment in time, that one moment in time, you know, when I was all that I thought I could be. And then it said underneath, remember, right when she says, all that I thought I could be, that's when she said, that's when h almost gets to 0. She says, that's the slope of the tangent line. It was written under there. You got to read that. When you guys go ahead and Google that video and just read the text. Find the English version. You'll like it a lot better. Yeah?
Did you used to be in choir?
Did I used to be in choir?
Yeah.
I used to live in choir. When I was at Drake, I don't think I took, I don't know. I lived in the world of choir.
So, yeah.
Yeah. Yep. There it is. Tangent line. Thanks, Dan. What's that? Tangent line right there. You get the slope of the tangent line. As h goes to infinity, that little secant calculation, crazy enough, right here, that process, that physical sliding of h smaller and smaller of that function, you get, you star this will give you the slope of the tangent at a point. It'll give it to you at x. True story. So the deal is, once upon a time, people wanted to know. They're like, yeah, I can do average rate of change, no problem. They've known that for years. But what about at a moment, a specific time? And they went and did this calculation. By the way, this little formula here is what allows us to get all the cool, easy ways to calculate the slope of a tangent at a point quickly. There are quick rules. We'll get to those. As we do the long way about 10 times, you finally go, you start seeing a pattern, you go, wait a second. I've been doing the long way 10 times. Can I just go like this? And yeah, you'd be right. There's a shortcut. All right. To the next blank screen. You ready to roll with me? So your classmates' last block, we graph something. You got to have a calculator in hand. Get a calculator. Borrow mine. I have one on my desk that you can borrow. It's the only one I got. We're going to take and graph one little function, x cubed minus 2x minus 3. That's the function we're going to graph. Go to your calculator. There's the function we're going for. So put it in y1 if you would, por favor. Go in there. What we're going to calculate is this average rate of change thingy bobber. I'm going to help you put it in your calculator and do it what we call numerically. You can tell me the slope. We're going to make 0, that h that we slid back, we're going to shrink that h down in an actual problem so that you can see it works. It'll give you the slope at a point. Okay. So first in y1, you want to put x cubed minus 2x minus 3. Go zoom 6 once you get it. Of course, I told you to. Yes. Yeah, I would be like a really parental answer, but no. Yeah, because it would be helpful in learning.
So it's just a random equation.
It's a good equation. I chose it because I liked it. So less random, more helpful in the future. Okay, zoom 6 it so you can see it. I want you to know what it looks like. Not a big deal, but there's your picture right there. What I'd like to know is, I'd like to know the slope of the tangent x equals -2. So I'm going to put right there, -2, we're going to do the slope of the tangent. We're going to use this calculation. So what's going to happen is I do need to do a little screenshot here so I can do this. Come on, Kev. Come on, work for me.
How do you have the slope of a point?
Ugh. There we go. Need the clicky click. Thank you for working, computer. So what I'm going to do is go right here. I want to know that slope right there.
How do you have the slope of the point?
At a point, that's my speedometer reading. So here I am traveling to, let's put up my drawing here. Here we went, stopped in Lakeville, went to Albert Lee, went to Mason City. What I'm interested in is not that over that 2.5 hours I went 120 miles. What I really want to know, maybe because I'm an officer of the law and I thought this dude in the gold minivan is out of control.
So it's like instantaneous velocity.
Yes, I want to know instantaneous velocity, which is the slope of a tangent line at a point. It's your speedometer reading. Thanks for clarifying that. That is a very good question. That tangent line says, what's your speedometer read at that moment? Well, we're going to do it over here in this graph too. At -2, I want to know that slope. The way we're going to do it, though, is we're going to start with a secant line here, back to the origin. And what we're going to do is shrink that h back. So this would be like my x right here, -2. This would be x plus h would be the 0 I have right there. Okay. Now x is -2. It's not just some random number now. So I'm actually using -2. And I'm going to use 0. This spot right there is my 2 spots over. Okay. I'm going to delete this so you can see what I'm talking about on an actual calculator. It helps, I promise. Okay, and got it. Here. So if I go back to my little equation here, I'm going to go to the big screen. This is what I'm going to put in. The limit as h approaches 0 of f of, do you remember it was x plus h? Well, I'm using x equals -2. So watch out. I want you to write carefully. I'll explain it in 2 shakes, I promise. Oops, that's not supposed to be there. Wait, eraser, don't write that. I forgot to put it, that's a -2. Okay, sorry about that. Okay, there you are. That means instead of x, do you remember x used to be right here and here? Well, I'm not guessing. It's not random. It's -2. That's the place I want to know the slope. So this will give me the slope of the tangent at x equals -2. A little crazy, but I want you to know it works. Okay. Now I'm going to stop this recording. I'm going to start a new one. Do you know what we actually do with this? It's kind of a rhetorical question. That thing is going to get put into the function f for x. Right? In all those places you see an x, we're putting -2 plus h. That's what it means. Put it in there. Then we're going to put -2 into the function here. So we're going to just expand this out. It's just going to have a bunch of stuff written all out. You ready for that? I got to stop my recording. And we're going to take